Welcome, everyone. My name is Peter Corliss, Director of Technical Advocacy at ScyllaDB. I'll be your host for today's webinar, Eliminating Volatile Latencies inside Rakuten's NoSql Migration. Today, you will learn about how Rakuten, the online retailing powerhouse, operates at scale and how they eliminated volatile latencies to continuously scale their global business. First, a little about ScyllaDB. ScyllaDB is a monstrously fast and scalable NoSql distributed database, perfect for highly available, highly performant terabyte scale workloads. It was patterned after Apache Cassandra and also offers an Amazon DynamoDB compatible API. Here's a quick snapshot of some of the many companies using ScyllaDB. As you can see, it's not just one industry. Anyone looking to run a big, fast, always-on distributed database can use us. You can start small and keep scaling. There's no barriers to hit as your company or your use cases grow. Without any further ado, I have the pleasure of introducing to you our speaker today, Hitesh Shah, Senior Engineering Manager at Rakuten. In more than a half decade at Rakuten, Hitesh has risen repeatedly through the ranks to a position of technology leadership. Before Rakuten, Hitesh has extensive industry experience, having worked for Ask.com, PayPal, and Salesforce. I personally want to thank Hitesh for setting aside some of his valuable time to prepare this talk and to speak with our community today. Please take it away, Hitesh.
Thank you, Peter. Really appreciate your brief introduction. If you can go to the, if you can keep the previous slide, please. Sorry.
Oh, certainly. Sorry about that.
No, it is. Thank you. Yeah, so brief introduction about me. I have been with Rakuten for almost, I would say, five and a half, 6 years by now. And I have participated as well as seen the catalog platform growth here at eBay/Rakuten. I'm truly a passionate engineer at the heart. I would say predominantly I have worked with the various technology firms, and pushing the envelope of the technology is what I love, on a day-to-day basis, and that's what I try to do at Rakuten as well. I also pride myself in having a very good focus on development aspects as well as the operations aspects of the product development. And my current interest includes pretty much I would say distributed systems as well as dynamically scalable platform. So it's definitely my pleasure to hear and share with you all your our experiences in terms of the using Cassandra as well as migrating to ScyllaDB. Next, please. Yeah, so in terms of today's agenda, I'm going to start with the overview of Rakuten Catalog Platform. And then we will kind of dive into, let's say if you're, generically looking at a catalog platform, how will you go about, what are the use cases you might need to consider, as well as what are some of the backend technology choices you may have to do, and particularly in terms of the database persistent layer, why will you, I'll make a case, why Cassandra makes the logical choice as a first class, persistent layer essence, right? And then once I have made a case for Cassandra, I will run into some of the challenges we have internally seen with Cassandra and why we started looking into ScyllaDB a couple of years back. And once I have made the case for ScyllaDB, I'll kind of share some of our experience in terms of migrating from Cassandra to ScyllaDB, as well as once we migrated, what were the post migration KPI results we have kind of like improvements and everything we have seen in our technology stack, as well as I will kind of like to share with you some of the lessons we have learned as a part of this journey. So if anybody on the call is thinking about similar migration, they can kind of take away those lessons. And at the end, we'll spend some time on some of the ScyllaDB concerns I would like to definitely highlight, so that kind of to share some of our experiences in that regard as well. Next, please. So let's start with an overview of the Rakuten Catalog Platform. So Rakuten Catalog Platform basically, powers the catalog platform of Rakuten.com. So let's say if you're into e-commerce and online shopping, and let's say if you're into cashback and everything, and hopefully you're also a Rakuten.com member. But let's say you're looking for a new iPhone, right? And then you're searching for a new iPhone. So you go to Rakuten.com and you start looking for an iPhone, and then you search for iPhone, and then you will see the search results saying that iPhone from, let's say, Groupon at certain price, iPhone from Sam's Club at certain price, iPhone from JCPenney at certain price. So those search results are pretty much powered by this platform. And we are, the RCP or Rakuten Catalog Platform is truly a global platform, and we are responsible for many of the global assets across Rakuten worldwide. So let's say if you're in Japan, you go to rakuten.co.jp on the right hand side, and let's say you're looking for a new iPhone and you search for iPhone. So you get the search results saying that, iPhone from certain vendor or merchant in the marketplace, at certain price, as well as, iPhone from certain different merchant at certain price with certain deals. So again, those search results are powered by this platform. Next slide, please. And the way in which we do that is that, we give you a brief, very high level overview of the architecture. Is we source the catalog data from multiple sources, multiple channels, and behind it is there's an offline data processing engine, as you can see, the green box in the middle. So it's basically a data processing engine pipeline, which basically, I would say, transform the data from multiple sources into single internal format, normalize the data, validate the data, cleanse the data, and basically, we have internal data enrichment, much ML-based algorithms. So, we have different teams within RCP, which are getting integrated with the queuing-based mechanism, So the catalog data will, as you can see, will get enriched by the machine learning models and will get kind of stored into the pipeline or the internal DB store. So the main point here is that this whole platform, as you can see in the middle green box, is powered by ScyllaDB. I mean, you can pretty much that ScyllaDB is kind of supporting and powering this catalog platform across worldwide. And just to give you a flavor of some of the technologies we are using internally. Spark, ScyllaDB, as I said, Redis, Kafka. We are also running in Google Cloud Platform or GCP. So pretty much we are using, PubSub as well as Dataprog, Dataflow kind of technologies. And if when it comes to the programming model, I would say, pretty much I would say we are leveraging all the three programming models around batching, micro batching, as well as streaming actually. So next slide, if you can go to. So quickly covering some of the data processing volumes which are being supported and handled by this platform. The total catalog items are, I would say, close to 1 billion plus by now. The number of transactions, the number of items we are processing on a daily basis is close to, I would say, 250 million plus, which roughly speaking, will translate into read QPS of, I would say, anywhere from 10K to 15K per Scylla node. Similarly, the write QPS will translate into anywhere from 3K to 5K per Scylla node. So as I mentioned earlier, the platform has been growing tremendously, and as you can see on the right hand side, the chart. Just 1 year back, I would say in Q1 of 2021, we were at 450 million listings or items in the catalog. Q2 we were at, I would say, already 600 million. Sometime in Q3 we reached 800 million, and right now we are already at 1 billion plus items in the catalog. Next slide. So this is some of the internal, monitoring Grafana charts I captured to show the QPS basically. So on the left-hand side, you can see the read QPS pretty much in the range of 8K to 8K to 10K, and peak around 10, 11K, 12K, and on the bottom right is basically the write QPS. Anywhere from 3K to 5K, and basically in that range actually, right? The peak is around 5K, 4K, 5K actually. So main point is the servers. It's a very heavy transaction oriented system, as well as servers are Scylla nodes are super busy. Next slide. So we'll now dive into after giving an overview of the RCP or Rakuten Catalog Platform, I will now kind of take you into the journey of, let's say, if somebody has to start from scratch a product catalog platform, then how will they go about it? And then what are the technologies we'll consider? Next slide. So let's say if anyone on the call or in general, anyone, if they are considering building a product catalog, then what are some of the key features for you to keep in mind, as well as what are the use cases you need to worry about predominantly, I would say, right? So one of the main aspects of the product catalog pipeline or the platform will be the near real-time updates in terms of the price updates and the near real-time availability updates. And the reason for these is that the merchants or the retailers are constantly changing the price, as well as as the items are getting sold out, they run into out of stock and other situations like that. And particularly around Black Friday, Cyber Monday, they are constantly changing price based on the deals available and everything. So in those situations, it becomes very, very important for the platform to propagate the price updates from the retailer to the e-commerce website in as soon as possible or near real-time manner. Because if the price are not matching, price are out of date, then whenever a customer is trying to order from the retailer, by visiting certain links, then they might not get the same deal, or basically retailers might end up paying penalty for mismatching the price. Similarly, if certain items are not available, no longer available because they are moving really, really fast, and then if that doesn't get propagated to the e-commerce website, then where it will basically have I would say, negative user experience, because if the customer lands up clicking on the link and then they go to the retailer website and the merchant is already out of stock, then that's not going to help them. That's a waste of time. So I think so those first two items are extremely critical. Some of the other things, let's say if you're looking at a product catalog platform, then some of the other key items you might want to keep in mind is that over a period you want to figure out the top trending products, right? Let's say around holiday period or around sales around Memorial Day or other critical events, when certain items are moving really, really fast. I mean, as an e-commerce retailer, you want to really kind of detect those immediately, so they can you can promote them and you can sell them and make profit out of them, right? So some of the analytics aspects around the top trending products or discovering purchasing trends is very important. Similarly, over a period when you have your ecosystem as well as your user community, then you might internally you want to detect the user preferences, so you can personalize the experience, right? So I mean, my main point is there is a lot of analytics needs on a particular platform, and at the same time, as I mentioned earlier, it needs to be able to support a large volume of data, as well as the fast growing catalog in a short period of time, as well as ability to support the enrichment, because for the platform, the data you might be receiving, the sources might not have a structured data, so you might want to derive the meaning and basically enrich the data. So that's another key requirement, and one of the most important requirement is obviously it has to be low latency, so you can basically move the things faster through the pipeline. Next slide. So having made the case for product catalog, if you have to start from scratch, what kind of use cases you would consider? Let me make a case that why Cassandra will be the first class choice in such a pipeline, and definitely we landed up selecting Cassandra because that was the most natural choice for us. And some of the reason, let me just walk through some of the reasons we landed up selecting Cassandra. Was one of the main reasons was that definitely Cassandra is highly scalable, I will say horizontally scalable database. So we're definitely very natural. Scaling Cassandra is definitely very natural. Cassandra is also very, very effective with the huge amount of data. You can easily add few nodes, and the data will start replicating to the new nodes, and then you can easily have it horizontally scalable, and the new nodes can basically start serving the traffic, right? The Cassandra also is designed as well as implemented for fast writes or append only writes. So the way with Cassandra works is that whenever there's an insert, you have a quick quick turnaround in terms of propagating the database updates to the database. And these also the way in which Cassandra architecture is designed, that it is done in such a fashion without impacting the reads. And this is mainly due to the Cassandra's the leaders and replicas architecture, or the sharding architecture, or the distributed. The reads are distributed, and the writes are also kind of up and only, right? So in terms of the performance, definitely Cassandra scalability wise as well as performance wise, will make definitely more sense. Now, Cassandra, when you look at the NoSQL based on your volume and transaction volume as well as data volume, when you're looking at the NoSQL domain space, Cassandra is more of a column family store, and that definitely made a lot of sense for us because, as I mentioned earlier, we have these use cases around enriching the subset of the data out of the whole catalog. So in that case, we don't want to update the whole item data. We just want to update subset of the data, right? And so we don't want to log the whole row. So that way, column family databases comes very, very handy. So you can just update the subset of the data without impacting the operations on the other columns in the same row. And again, as I mentioned earlier, speed of deployment is very easy with Cassandra. Spin up a new node, data starts replicating, and the traffic will start getting served. And again, I think based on the read and write performance, I think analytics wise also Cassandra was definitely a natural choice. Next slide, please. So having made the case for giving the overview of RCP, as well as if someone has to do the product catalog from scratch, why you have to use Cassandra, and why we were using Cassandra. Let me go into why we landed up looking at ScyllaDB and why we landed up migrating to ScyllaDB. Next slide, please. So as our platform was growing, and we have been using Cassandra for, I will say, almost 3 to 4 years. We switched to ScyllaDB, by the way, 2.5 years back. So we're using Cassandra for almost, I will say, 3 plus 4 years actually, right? So some of the issues we started seeing as the platform was growing, some of the issues we started seeing Cassandra was like, one of the main issue was that Cassandra was inconsistent performance, right? So as I like to call it, the volatile latencies. So let's say if you take a particular select statement or select query on Cassandra, and it's returning the results, let's say maybe in 60 or 70 milliseconds, right? Then the same query will take, let's say, 120 or 130 milliseconds at a different time on the same day, or might even land up taking 140, 150, 160 milliseconds on a different day, right? So I will say basically with Cassandra, the latencies were all over the place, and that was creating challenge for us, because it was becoming very, very hard to predict the performance of the pipeline, and it was becoming kind of very hard to commit to the SLAs to our partners and our internal customers, right? So that was one of the main issues. Cassandra being a Java-based stack, definitely it had its own baggage of JVM issues, and I would say that we had our own fair shares of out-of-memory issues as well, including long GC pauses. So suddenly, in the middle of the live traffic, one of the node will just suddenly freeze because of the long GC, and suddenly we'll start seeing client-side server connection timeouts, and it will impact the performance and etc. So one of the other reason was the single slow node in Cassandra can impact the whole cluster. Now this is generally, I would say, a normal occurrence with any distributed systems a bit, but it was much more predominant in Cassandra, and we were definitely very, very impacted by these. And the reason for this occurring is because any distributed system, they have, as I mentioned earlier, they have this architecture of sharding and replicas and leader. So there is a lot of I would say peer-to-peer network chatter going behind the scene. So if a particular slow node, if for any reason, if one of the nodes starts slowing down, then it will kind of like start lagging behind in terms of processing the messages coming to it, as well as propagating the messages to the subsequent node. And pretty soon the whole slowness will start propagating to the rest of the cluster, and your whole cluster will start coming down. Some of the other issues with Cassandra, again, requires a lot of manual operations, pretty much babysitting all the repair operations and everything. In our case, we essentially pretty much had to dedicate a full-time DBA just to make sure Cassandra was running actually, right? And so given all these challenges, we would definitely tackle all the Cassandra challenges. But I think what we started realizing was that, the horizontal scalability in Cassandra was coming at a steep cost. So next slide, please. So that's when I think a couple of years back, 2.5 years back, we internally started reviewing and started internalizing that for the next stage of the growth of the platform, Cassandra was not going to be the answer. So then we started looking around, and then we bumped into ScyllaDB, and that made obviously natural first choice. And the reason for that was that ScyllaDB is pretty much a Cassandra written in C++, right? So we started looking into ScyllaDB and kind of like started getting serious about it. And there were a lot of reasons we started looking into it. So let me just quickly run through them. One of the main reason was that Scylla was I would say 5 times to 6 times faster in terms of the performance right out of the box. So that was one of the salient point. And because it was faster, it was I would say much more improved total cost of ownership, as well as because the code is compared to Java, the code is written in C++. So definitely much better ROI on the same set of hardware, right? So that was another point which kind of appealed to me. One of the other things we observed with Scylla was that it was consistent performance was very consistent. So when I explained this to you about around inconsistent latencies with Cassandra, with Scylla we saw that it was definitely consistent latencies. The query will perform in pretty much around the same response time at any time of the day, right? So these kind of like gave us, I would say, huge peace of mind, and we kind of like started becoming comfortable about committing to coming up with the SLS, as well as committing to SLS to our internal partners as well as customers. And some of other key points around ScyllaDB why we got attracted was one of the main reasons is obviously it is built on the C# framework, which kind of like given the shard per core approach of ScyllaDB, this reduces the kernel level contention substantially, right? And then improves the parallelism much better. So that was another reason. And again, I think one of the biggest appeal, at least in our case, was that it's just pretty much a drop-in replacement. So you can, if you have your pipeline or application running on Cassandra, spin up new Scylla nodes, right? Basically, and then migrate the data, and then start pointing your application. You just change your config to point to the Scylla cluster, and boom, your application will start running. So that was another big positive actually. Next slide, please. So as we started looking into ScyllaDB and we got more and more convinced about ScyllaDB and committing to Scylla, we also kind of like started realizing that because it was a new technology, probably ScyllaDB Enterprise might make sense for us. So we started looking into ScyllaDB Enterprise, and we kind of actually definitely settled in ScyllaDB Enterprise. And some of the main reasons we did that was because the enterprise version has the very good support. There's a private Slack channel with the customers with committed SLS, and we have definitely been able to use those pretty well actually. So that was one of the main point. For enterprise customer, ScyllaDB also has the shard aware driver, so which kind of made sense for us. Then the enterprise version also have a ICS or incremental complexity strategy. So I think at least in our case, we have this one particular table which is very heavy transaction oriented, with tons and tons of reads as well as tons and tons of writes happening in parallel, as well as because of lots of writes on the table, resulting into a lot of tombstones and everything. So incremental complexity strategy made a lot of sense for us to optimize our, I would say, the disk space utilization as well as the the CPU and the memory and other resource utilization. So that was one of the good thing about the enterprise version. Workload prioritization is another salient feature of the enterprise version. I mean, we are still evaluating, but you can basically prioritize your core. I would say the core key transactional functions versus, let's say, non-core analytics jobs or the user experience aspects actually. So you definitely have that choice as well. And as I mentioned earlier, right, Cassandra pretty much required a lot of babysitting, whereas ScyllaDB had the ScyllaDB manager, which kind of reduced a lot of the demand on our DevOps DBA to kind of manage the operations of the cluster. Next slide, please. So having been through the journey of how will you go about catalog platform, why you will select Cassandra, and then why you should consider ScyllaDB. let me share some of our experiences in terms of, so what was our migration approach, and then, how did we go about it. So one of the first thing we did that we definitely wanted to, before committing, we definitely wanted to evaluate the ScyllaDB technology. So we came up with the evaluation methodology to kind of, go through, I will say, some POCs internally to convince ourselves that yes, ScyllaDB is the right technology, right? So in our platform, there were two primary use cases where basically there were basically kind of where we were seeing there were pain points in terms of, kind of like improving the performance as well as committing to SLA to the customer. So two primary use cases. One use case was on the data ingestion side, where we, as soon as the catalog data was coming in, we wanted to ingest it and normalize it and enrich it as soon as possible in matter of, I would say, minutes and matter of hours, rather than, waiting for, let's say, 4 or 6 hours or 8 hours, right? And once the data is enriched in our platform, we basically send the data to our partners, enrich the data, sent to partners. So there was a separate use case around that where we wanted to speed up those operations of exporting the data to our customers, right? So those were the two primary use cases. So we identified those two use cases, and basically we started executing upon a proof of concept phase or POC phase, where basically we started running our production code base, not the production pipeline, but the production code base into our test environment against ScyllaDB using the same production, I would say, data volumes, and to a certain extent, the production transaction volumes as well. So that was, I think, pretty much the approach we took. And then we kind of like went through multiple iterations of the ScyllaDB evaluation, POC evaluations, because ScyllaDB definitely, I think we had to test with, multiple topologies or multiple configuration variations, right, in terms of the number of cores or the memory or the number of nodes and everything. So we went through all these multiple iterations, and then and towards the end, when we were kind of like when we started getting engaged with the Scylla team, we also kind of became aware about the SARD, our custom driver. So kind of we evaluated that as well towards the end to make sure to make sure that it made sense for us. Next slide. So here is just to share with you all, here is an internal screen capture I captured during our internal POC. So for the ScyllaDB driver, so on the top left, you can see that, the classic or the traditional data sets driver, and how the coordinator will be busy or not, basically what is the load on coordinator. And on the bottom right, you can see the ScyllaDB custom ScyllaDB driver, and you can see there is a much more improved parallelism in the Scylla driver. And basically, at least in our case, we saw the improvement of anywhere from 15% to 20% in some of our query performances. So next slide. All right, so after going through all these evaluation and POC and everything, it was basically time to make a decision. So that's when basically we kind of like started engaging with the ScyllaDB, kind of started getting their more input to understand the pricing and how things will look like with the enterprise version support and everything, and kind of like went through the internal evaluation of the benchmarks and the data and everything, and kind of like we kind of made the final decision to commit to ScyllaDB. And once we did that, we again, I think, back and forth with the ScyllaDB and kind of like try to understand, what should be the ideal production configuration. So we kind of like finalized the production topology and production configuration, and then we became serious about going live with ScyllaDB. So we started planning the live database migration. And since it was a new technology for us, I mean, definitely Cassandra concepts and everything applied, but at least in terms of the operations as well as kind of understanding some of the metrics and monitoring, it was a new stack for us. We went through a couple of rounds of training with the ScyllaDB team, and kind of like start warming up as well as ramping up our internal engineering team as well as the DevOps team towards the ScyllaDB. So I think that's kind of, I would say, the overall migration approach was. So next slide, please. And just to share some of the details around the actual production migration. So I think this was, I will say, the most critical aspect of the whole migration. Basically going live with the ScyllaDB replacing Cassandra in production. So I mean, you can pretty much imagine that we have this production pipeline running with millions and millions of transactions on a day-to-day basis with terabytes and terabytes of data. And then in that, if you have to switch Cassandra with ScyllaDB, it's pretty much like you can imagine, changing the engine of the plane midair when the plane is flying, right? So it was definitely an extremely challenging maneuvering and complex task actually. So once we, sharing that journey with you all, basically, so once we completed the evaluation and once we kind of like, signed the contract with ScyllaDB, we kind of like, did the final functional validation to make sure that, by switching to Scylla, there is no functional impact. So quickly went through that round. Then when it was time to do the actual migration in production, basically we kind of like commissioned the production cluster using the topology and the configuration which was recommended, as well as we felt it will make the best sense for us. So we commissioned the production cluster, then we took the backup of the Cassandra cluster, the database, and then basically stored the database in Cassandra ScyllaDB cluster. So because of our data volume, it kind of took a couple of days to restore the data in ScyllaDB. And the approach we took was basically pretty much the node, node tool rebuild cluster, or basically the node tool rebuild. I think we also use the cross data center approach to migrate from Cassandra to Scylla. So basically we just kicked off the node tool rebuild data center command, and then it took some time basically. So once all these things were done, the ScyllaDB cluster was ready. And once the ScyllaDB cluster was ready, because since it took like, I would say, 3 days or something. So basically we took the Cassandra database on N, and the Scylla was N plus, basically the Cassandra was N+3 and Scylla was still on the N backup, right? So we kind of replayed all the live production traffic as well as live production transactions back onto the ScyllaDB to bring it current with the N+3 or the current time, right? So once the ScyllaDB cluster was ready, the quick validation of the cluster, making sure data integrity and data looks good, switch the production configuration, production pipeline to ScyllaDB, and boom, in a matter of in an instantaneous moment, we were suddenly running on ScyllaDB. So that's how the production migration was. And basically, just like typical to any migration, I would say, right? Once we switched over, we monitored for production issues for a week or two, kind of like, work with the Scylla support team to kind of resolve some of that and basically get the guidance, and then kind of decommission the old Cassandra cluster. So that's how the overall production migration was in our case. Next slide, please. Yeah, so let me share some of the post-migration results we have seen in our case, and hopefully that will kind of help you understand the impact ScyllaDB has on our infra and our operations. Next slide. So to share with you some of the KPI improvements, as I mentioned earlier, the two main use cases we were considering was the feed ingestion, which definitely improved 30 to 35% in our case. So definitely improved SLS and committing SLS, etc. And the second use case, as I mentioned, sending enriched data to our partners, which also again we saw anywhere from 2.5 to 5 times improvement in publishing those feeds to our partners. And because of these, the partners as well as internal customers were much happier, because now the retailers, the price updates and the availability updates and any other updates to the catalog were getting propagated pretty much in a near real-time fashion. And last but not least, we went from 21 nodes in Cassandra to 6 nodes in ScyllaDB. So definitely, huge amount of hardware savings. And not only that, I think we are running, because since we are running, but by the sheer fact that we are running on GCP, we pay a lot of dollars to dynamically, dynamic hardware cost or dynamic, things like data proc and data flow. And because ScyllaDB was performing faster, we kind of like reduced those dynamic hardware cost as well. So that was another savings. Next slide. All right. So quickly let me run through some of the lessons we learned as a part of our migration, and hopefully that will help you, if anybody on the call or somebody is considering migration. So one of the main thing was that, at least in our case, the ScyllaDB evaluation cycle turned out to be a little bit lengthy because I think there was a lot of back and forth with the ScyllaDB as well as support, as well as their team, to understand the cluster configuration, ideal cluster configuration, product configuration, the setup process, the database migration process, etc., etc. Right. So essentially, the lengthy evaluation cycle turned out to be a little bit lengthy. The ScyllaDB as a technology is definitely complex, right? I mean, if you're used to working with Cassandra, it's all Java and out of memory errors and everything very easily understandable. If you're not used to running a C++ kind of a tech stack, definitely the ScyllaDB ramp up curve is non-trivial. Sorry. So sorry about that. So yeah, so as I said, the ScyllaDB ramp up curve is definitely non-trivial. One of the key thing was that sizing the ScyllaDB is not easy to understand, because I think you have to get that. It's definitely not a rocket science, but definitely you have to get the science right. And then at least in our case, finalizing the cluster topology or the server configuration was the main key. And just like any migration, but particularly true with any live production database migration, is definitely very challenging. So one must focus on detailed planning as well as tight execution and timely customer communication. Next slide, please. All right, so just a few things I want to share with based on our experience in terms of the ScyllaDB. Definitely, ScyllaDB has some negative. I shouldn't say negative, but the weaknesses as well, actually. So some of the concerns or some of the issues we saw with the ScyllaDB was definitely because it's a highly technical product, but there's a lack of documentation in a lot of the areas. And that's why basically, we ended up, going back and forth with ScyllaDB to try to understand their configurations and switches and, some of the other aspects. So that's definitely a great concern, actually. Just like any software, ScyllaDB is not a bug-free, of course, right? Essentially, so you got to figure out, what in your setup, what makes sense and what are the issues you are bumping into, and what are the solutions available for that from ScyllaDB in terms of the patches or bug fixes and everything. So something to keep in mind, basically, whether those bugs are going to impact your key critical production flow or not. And then just like as I mentioned earlier, because of the complexity of the technology, the operations of the ScyllaDB is also a little bit more complex, and the setup is also complex. But I think once everything is being done and said, the cluster will definitely run very smooth. And just one last point, the monitoring aspects of the ScyllaDB is not cheaper, I would say. So the monitoring stack itself is free, but the stack is very hardware resource intensive. So that's something probably you might want to keep in mind as well. Next slide, please.
All right, thank you, Hitesh. That was awesome. And thanks again, everyone. I just want to take a moment for a quick audience poll. For a sense of scale, we'd like to understand how much data do you have under management in your own transactional database systems? Less than a terabyte, 1 to 50 terabytes, 50 to 100 terabytes, or those power users out there that are managing 100 terabytes or more. Pick the answer that best matches your current data set. Thank you, and we'll leave the poll up for a bit for you to answer. Now it's time to hear from you, our audience. If you have any questions for Hitesh, please again use the Q&A button located at the bottom of your screen to ask your questions. Also, if you have any private questions you'd like to ask, please use the Contact Us form on our website at ScyllaDB.com. We've already had some questions asked during the presentation, so let's see what we already have queued up. Here's one. Did you have open source Apache Cassandra initially, or did you use the DataStax Enterprise Cassandra deployment?
We were using the open source Apache Cassandra development. So we did consider the DataStax Enterprise version as well, but I think because of our cluster size in those days, as well as kind of the enterprise cost required for the DataStax Enterprise version, we kind of like opted for, and we were very comfortable with the open source Apache Cassandra version.
Great. How was the traffic switch from Cassandra to Scylla, between the two clusters? Was it gradual or was it a one-shot approach?
It was a one-shot approach. So as I covered in my migration approach slide, basically the actual production migration slide. Let's say on the time period T, we kind of like took the backup of the Cassandra and started restoring the database data into the Scylla cluster, right? So that will be, let's say, T+2 or T+3, right? So while the Scylla cluster is being prepared with the T onward, with the data from T, the Cassandra production cluster is continuing the traffic, T+1, T+2, T+3, right? Essentially. So then we replayed the traffic because we had internal mechanisms to replay those transactions. So we moved over those files or those transactions and replayed on ScyllaDB. And as soon as ScyllaDB was ready, it was a single switch where in an instantaneous moment, the traffic started serving from ScyllaDB instead of the Cassandra.
Right, fantastic. Okay, so the question from Swaroop, I believe that you answered this already, but was there a reduction in the cluster node size from Cassandra when you did the ScyllaDB migration? So in fact, you talked about the number, but how about the size of the nodes? Was there any change to the size of the nodes you're using?
No, that's a great question. That's a great question, actually. So we are, I don't know if anyone is familiar with the GC, but we were on N1 high memory 12 or N1 high memory 16 on Cassandra, and we pretty much continued the same hardware footprint on Scylla. So it was reduction in the nodes with pretty much the same amount of core, right? But I will definitely, highlight that we did end up increasing the memory on the Scylla nodes. So each of the Cassandra cluster node, I think we were at 48 gigs or 64 gigs of RAM with the Scylla nodes, because of the recommendation from ScyllaDB as well as the memory requirements. I think we are running on 96 or 128 gig of kind of a RAM actually. Yeah, so definitely reduction in cluster with the same number of cores, but definitely increase in the memory.
Right, so from 21 nodes down to 6, but then more memory per node. Interesting.
Yeah.
Nice.
Yeah.
Thank you. And thanks for the question. Here's another one. Was there any issue in latency with bulk writes because you might be writing to different nodes?
Was there any issue with latency with
bulk writes? Yeah.
No, not in our case actually. In fact, I have seen actually ScyllaDB performing actually much faster. And I think if I understand your question correctly, what you might be trying to understand is whether the right. So I think it also depends on the quorum you are using, right? So we, at least in our writes, we are using a one node level 1 quorum level 1. So our writes make sure that write is written to a particular node as well as at least one more node actually, right? So and we kept pretty much the same configuration on ScyllaDB, and even with the same quorum configuration in the ScyllaDB, the writes were fast actually. So short answer is no, we didn't have any issues, but hopefully I answered your question, Tanmay.
Yeah, and then so you're using a replication factor of 3 and a quorum, so 2 of the 3. Did you try and measure how long it took to get data to be consistent, like all 3 of 3 across the nodes? Did you do anything like that?
No, so we haven't. We didn't look into how much time internally it will take to propagate the data to all the 3 nodes. Definitely, I don't have that data in front of me, but definitely I can speak to that. Because I have internal metrics where I monitor the client side latency of the DB nodes, whether it's Cassandra or Scylla, on every 4 hour, right? So, and it's the same query with the same query or same Spark jobs gets executed, and we kind of measure the time it takes, right? So in Cassandra world, that query was taking anywhere from 60 milliseconds, 70 milliseconds, etc. And lately, I have seen with our ScyllaDB cluster, the same query is taking anywhere from 24 milliseconds, 30 milliseconds, 35 milliseconds, right? So and it is also fairly stable and consistent.
Nice. So here's another question. How many regions or zones does Rakuten deploy across their database across?
Correct. Yeah. So that's a great question, Peter. Actually, so we are in Google Cloud Platform. So they have a concept of region as well as zones. So we are, because of the complexities as well as some other factors, we are not cross region, because that involves a lot of cross data center replication and everything. But if definitely within a particular geographic region, we have kind of distributed across multiple zones. So Google Cloud has a zones called zone A, B, C. So we are across all the three zones in a particular region.
Mm-hmm. Okay, and taking a look at your block diagram, you have Elasticsearch as well as ScyllaDB. How do you keep those two in sync? What's your method of making sure those stay in sync? Do you use Scylla's new CDC capabilities, change data capture?
Yeah, so that's another great question, Peter. No, so we haven't looked into the CDC capability yet. The way in which we keep the Elasticsearch cluster in sync is that, as I mentioned earlier, it's a pipeline where basically we have this lot of distributed Spark jobs essentially, and there is across different teams there is a queuing based integration, right? So as soon as the data is updated into the ScyllaDB, we publish a message to an internal queue, and then from there the data will get propagate into the Elasticsearch, right? So the way in which we have designed the pipeline is, as I mentioned earlier, is pretty much near real time. So Elasticsearch will be pretty much consistent with the ScyllaDB data, right? Now, in terms of the second part of your question, Peter, in terms of the CDC, so we haven't looked into the CDC yet, and the reason for that is we have our own built-in change detector mechanism, which is we call something called a delta manager, where basically we kind of like compare the using the checksum and few other algorithms. We compare the listing or the catalog data from a previous instance with the new instance, and only propagate the changes or only propagate the changed catalog items to the ScyllaDB. So we have our own built-in change detector as well as delta manager. Mm-hmm.
You're not alone, right? We've heard this from other people, and everybody had to invent their own mechanism for it. Fortunately, for people listening, we have this new change data capture mechanism. It can pump out data directly to a Kafka topic. And so for people looking to replicate what Rakuten has done, we've actually made it easier for people doing this from now on. The other thing I noticed was that you have doubled the data that you stored in a year to 1 billion listings. Are you looking to use TTLs or other methods to minimize the data that you have under management, or do you just plan to double the database again in another year or so?
Correct. Yeah. No. So that's another great question actually. So we definitely came across the TTL capability in the ScyllaDB, but the reason we are not using is that because we want to maintain the life cycle on our own. So we have our own internal life cycle mechanisms, implemented for the catalog data, where if the catalog data becomes stale after, let's say, n number of days, we kind of like we do a soft delete on those catalog items. And even after they are soft deleted, let's say even after n days of or m days of soft deletion, we actually completely physically drop those tables from Scylla. So physically drop those catalog data items from the database. Yes, so we have our own life cycles, and from that perspective, we didn't want to over-engineer or over-complicate our solution by also implementing TTL in ScyllaDB.
So I have another question then. So you have this gigantic product catalog, you say 1 billion items. What is the basis of your data model? How do you partition this? What's your clustering key look like? So could you talk a little bit more about the data model you use?
Correct. Yeah. So we have so basically so let me talk about this in a generic fashion, right? So any schema or any, hang on one second. Sorry about that. So any schema, any NoSQL schema, I would say, right? Basically, the key thing is that you need to identify the unique identifier, right? So we identified the unique identifier in our case, and then basically, and then it's also a multi-tenant platform, right? So you have to kind of like identify the unique ID, and then basically so you have to mix that with the multi-tenant partition key, right? So basically, so we use the multi-tenant key as well as the unique identifier, and partition the data based on that key. So I think I would say pretty much the data is partitioned on a kind of like tenant ID base, basically.
Right. And then in terms of your querying, did you find something like there is a hot product, or maybe one manufacturer versus another had like the day a new iPhone ships? Did you have anything in terms of hot partitions or large partitions that you need to manage?
Yeah, so that's a great question actually. So we do, so let me answer the question two ways actually, right? So in terms of the use case, yes, we do have a use case as I covered earlier around, doing the finding the top trending products and kind of like something is moving really fast and we want to bubble up, right? But the way in which we implemented that is via the I would say the offline analytics job, right? So basically we kind of like as the data is getting switched shipped to Elasticsearch and few other things, we also kind of like have the pretty much I would say on a 4-hour basis, we kind of like do the latest product calculations and derive the top trending products actually, right? But those are being stored in a separate Elasticsearch or the Elasticsearch instance. So yes, so we do have that trending analytics, but it is being calculated offline using the ScyllaDB data and being indexed into the Elasticsearch to serve dynamically separately, right? So so that particular use case did not result into hot partitions in our case, but at the same time, as I mentioned, the when I talked about the ICS or incremental compaction strategy, we have this key schema or key table in the catalog, which results into a lot of reads as well as the tons of writes in parallel, concurrent, basically, and that table definitely have the hot partition problem.
Got it. Got it. Since you said your cluster is serving millions of requests on the same day, are you facing any rewrite latency or timeout issues during the time of repair?
No, not in the context of ScyllaDB. We did used to have those issues with Cassandra, but we haven't seen them in ScyllaDB. No.
Yeah, yeah. So for people who aren't familiar, Scylla has a system called row-based repair, right? So it's doing repairs on a much more granular level. So you don't see those kind of like, again, it's the database equivalent of a stop the world pause, right? So the repairs have a much lower impact. And with our IO scheduler, those go in a way to be unobtrusive to your read writes on normal transactions. So that's a great question. Thanks. And then we have another question here. As per my understanding in the block diagram, Spark jobs are loading to ScyllaDB. Has there been any change of performance in it since the migration?
Yeah, so as I said, actually, our feed ingestion use case, anywhere from 35 to 40% improvement. I think 35 plus 30 to 35% improvement. And so that's the improvement we have seen in our Spark job performance, basically.
Right. And here's another question. What maintenance operations do you run periodically in Scylla?
That's a great question, actually. So basically in the Cassandra world, we used to do repairs pretty frequently, actually. I think repairs is the only thing I can think of, basically. So with the ScyllaDB Enterprise, a lot of the things are built automatically, and even the repairs are getting scheduled automatically. So I would say pretty much, repairs is the main thing, where basically you need to make sure that, your tombstones are cleaned up before that 10-day grace period, so that your nodes are data integrated in terms of, data integrity perspective. So I think repairs is the main, and obviously the regular backups, right? The daily backups and the hourly backups and the weekly backups.
How about compactions? Do you run those?
Yeah, so I think those things happen automatically internally, right? So I think the way with the compaction works is that in your Cassandra or ScyllaDB, you define the table level compaction strategy, which I mentioned earlier was basically the incremental in our case. We can also use the size based, size based as well as tier based compaction, etc. But once you define those will happen automatically within ScyllaDB.
Exactly. And so with the incremental compaction strategy, for people who aren't familiar with it, normally on Cassandra, you need to leave half of your disk space utterly free, like you can't even use it because that's used for these major compactions. But with incremental compaction strategy, you can actually use like 85, even 90% of your disk space. So only 10% is set aside for those compactions. So you actually get better disk utility as well.
Correct.
So that's a great question. Thank you for asking it. And in fact, thank you everybody for all of your questions. I'd like to thank you all very much for attending today. In due time, you will find this presentation available on ScyllaDB.com, on our homepage in our webinar section for on-demand viewing. Also remember to register for the upcoming webinars. And for now, on behalf of Hitesh and myself and all of us at ScyllaDB, enjoy the rest of your day.